this is basically a line integral problem, and here we are supposed to find the work done by this vector field along this triangular path. So suppose we are breaking this path from this one is one path 0 to A, then this is our second path A to B, and this is our third path. And we are supposed to find what will be the work done. Work done is the formula for work done is F dot dr, going from 0 to A to B to 0 again. So this is a closed path, then we are supposed to find a closed loop integral of this F. So this is our work done formula. So we break this work done, this line integral in terms of three parts. So first we will be finding for part 1, second part 2, then part 3. Now to solve this, let us see what is happening in this part 1. During this part 1, you see the x value is 0 everywhere. Y is changing from 0 to A, and Z is also 0. So this time we have to write x is 0, y is changing from 0 to 1, and Z is 0. In general, we write dr in Cartesian coordinate system, where it is like x cap dx, y cap dy, and z cap dz. Now because along path 1 x is constant, z is constant, so dx will become 0, also dz will become 0. So what I mean is only dy, which will not be 0, because we know that our y is changing. So combining all these three, our dr vector along path 1 is basically like a. So our work done along path 1 will become F dot dr. See, now F is having all the three components, but because our dr is having only y cap component, rest of the components will not contribute in the work done. This thing will only remain, it will become y z square dy. What is the limit for y? Y is going from 0 to 1. So we will be writing the limit for y to be equal to 0 to 1. Now, because here our z is constant, which is equal to 0, so in place of this z, we have to write 0. So once we write 0, this integral becomes 0. So answer for the along path 1 is equal to 0. Similarly, if we do it for path 3, because path 3 is easier than 2, let us do it first. So path 3, if you do, you see along this our x is constant because it is along z axis. Again our x is 0. What about y? You see this coordinate at the coordinate of y along this at this point is 0. Similarly at this point is 0, and it's also straight line, so it is actually 0. But our z is changing. From how it is changing? It is changing from z is equal to 2 to z is equal to 0. So because our x and y are constant, that is why dx equal to dy is equal to 0. Now dz is not 0. Combining these three, we write dr. dr will be equal to z cap dz. Therefore, work done along path 3 will become f dot dz z cap. Z limit will go from 2 to 0. We should not reverse it. If we reverse it, then the answer will become opposite, which is not correct. F dot dz z cap. So that will be 6y plus z, 6y plus z dz. Then because y is 0, so we can simply substitute it to be 0. Our integral is simply becoming 2 to 0 z dz. which is z square by 2 to 0. If you substitute 0 square by 2, 0 minus 4 square by 2 square by 2, which will become 2. Sorry. So our two parts are done, but the next is to find how to find the work done in along part 2. If you look at the part 2, what is constant? Along on this, because it is on the x1 plane, our x is equal to 0. However, our y is changing. How y is changing? Y is changing from 1 to 0. What about z? Z is also changing from 0 to 2. So we can say that our dx is equal to 0. However, our dy is not equal to 0. Also, our dz is not equal to 0. So if we need to find dy vector, we will write it as dy y cap plus dz z cap. Now let us write the work done along part 3, which will become f dot dr. Now f is dr is having y cap and z cap both components, so we will be writing y z square dy plus 6y plus z dz. 6y plus z cap dot, this will become 0. Only this part will survive, so that is why we are writing this. Before I write the limits, let us see that along this, because our z is not constant, you cannot simply ignore this z, or we cannot take this z out of the integral. So we have to write our z in terms of y in order to do this integral with respect to y. Similarly, for this we have to do it. We have to replace our y in terms of z. Or either you change this z in terms of y. How to do it? Because this A to B line is a straight line, there will be a relation between y and z. And how to find this equation, relation between y and z? For that, we can do it like this. So y minus y0 by y1 minus y0 equal to z minus z0 by z1 minus z0. This will be the equation of this straight line passing through 2 points. So now, suppose our y0 point, y0 z0 point is this, and y1 z1 point is this, then we can write it as y minus 1 divided by 0 minus 1 equal to z minus 0 divided by 2 minus 0. So now we simplify it, we got it there. Our y minus 1 times of 2 is actually equal to minus z. This our z is equal to minus 2y plus 2. In fact, you can also look at it like this, because we know that this height is 2 and this is 1. You can say that the slope of this line, which is m, will be equal to pi by x. So this is 2 by 1. Also, we know that this is actually inclined along this. So this slope will be negative. So we know the slope, and also it is cutting the intercept z axis at 2. So we can simply also write it like that, minus m, or y is equal to minus m times of z plus c. So this will be written as z is equal to minus my plus c. So we got the same equation. Now we know that z is equal to this. So what we can do is we can find our dz, which will be equal to minus 2 dy from here. Now we will substitute on this. So w3 will become integral of y 2 minus 2y whole square dy plus 6y minus 2y plus 2 minus 2d. Now the entire integral is in terms of y. So we can put the limit for y, and y is changing from 1 to 0. Rest is simple, we just have to simplify it and finally do the integral. Y will go from 1 to 0, dy let me take it out. This thing will become y into 2 square will become 4 plus 4y square minus 2 into a into b 8y plus minus 2 into 6 12y plus 4y minus 4. So once you have this, you can further simplify it. It will become 1 to 0 integral dy 4y plus 4y squared minus 8y squared 4y. Sorry, this will be yk, and here it will be simplifying this will be giving us 8y minus 4. So in fact, even after simplifying this, we will get 4y minus 8y will give 4y minus 8y squared plus 4y cubed minus 4. So this will give minus 4y squared by 2. This will give y 8y cubed by 3. 4y to the power 4 by 4 minus 4y. Now put the limits 1 to 0. So this will give, and first if you put y equal to 0, everything will become 0. Minus. Now you put 1. This will give 2 minus 8 by 3. So minus 2 minus 8 by 3 plus 1 minus 4. So this will become minus 2 minus 4 minus 6 plus 1 minus 5. 5 plus 8 by 3. So this will give us 23 by 3, I think. So we have got our total work done, which is W1 plus W2 plus W3 to be equal to minus 2 plus 23 by 3. This is 70 by 3. So this is how you can solve this question number 5. Now in fact, if you look at this problem, you can also relate it to Stokes' law, because it is a closed loop. It is a closed loop, and we can simply change it to Stokes' theorem. So let us write the Stokes' theorem first. Stokes' theorem states that if you have a closed loop integral f dot dr, you can convert it to surface integral. This is our loop integral, so you convert it to surface integral. This can be converted as del cross f dot d. Okay, so if you want to solve through Stokes' law, we have to find del cross f dot d. Before I find this del cross f dot d, let us find t. Because this plane is on yz plane, this loop is on yz plane, so the area vector will point along x cap. If you curl your fingers along the path, the diagram will give the direction of the n cap vector, area vector. So we got that our area vector is actually along x cap. So we can write that our area, small area element will be x cap dy dz. So what we have to do is we have to find del cross f now, and we do not have to find complete del cross f. We just need to find the component of x cap, because finally we will be doing del cross a dot d. So here we will be writing f x, f y f z raised to 10. We have solved this earlier. So our f is 8 I cap, y z squared j cap, and 6y plus z k cap. So in place of fx we will have 8. In place of fy we have 1z squared, and in place of fz we have 6y plus z. Now let us find the component of x cap. Del y of t. So this will be 6 minus del z of this thing. This will give us 2y minus y cap, and something will come. Z cap into something will come, which we will not require. Why? Because finally we want to find del cross f dot t. So this will become 6 minus 2yz dy dz. Okay. Now doing this integral is also very important. Like it's a little bit difficult. You have to look that this y and z limits are not actually independent. So how you think it? Like this. If you go y distance here, your limit for z will go from here to here. Okay, but if you are here somewhere here, your limit for z will start from the same, but ending is different. Okay, anyway, we have already found that this equation is z is equal to minus 2y plus 2. So your z limits are actually depending on the y position you have chosen. So first we will do the integral along y. Let us take the dz integral out. So we will write it 6 minus 2yz dy. For your 6y, your z will go from this y equal to z equal to 0 to z is equal to this constant. Okay, I have to write it here. First we are doing the z integral. We are finding this. Then we will be finding dy integral. It will go from 0 to minus 2y plus 2. Then our y will go from, after doing this integral, after completing the z integral, then we will go from y equal to 0 to this point. This point is actually y is equal to 1 minus. Yeah. This integral we have to find. So now we have got that our d integral is equal to 0 to 1 dy 6 minus 2yz. This will become 6z minus 2y z squared by 2. Okay. And the limit is 0 to minus 2y plus 2. Finally, you will have the integral equal to dy 6 minus 2y plus 2 minus y minus 2y plus 2 whole square. Now this integral is only on 1. Simplify it. It will come out to be equal to 17. If you look at the integral of this in the previous, using the normal loop integral formula, you get the same thing. And this is how you can also verify the Stokes theorem. So what you have to do is you have to remember this. If you solve this problem, you will get many information like how to find curl, how to write the n cap, how to write the area element, how to do this two-dimensional integral, why we have to put this limit minus 2y plus 2, not something constant, like not where 0 to 2 we are putting, why we are not putting 2. That give you, this is very critical. And after this, once you convert it, this is simple. And before that, what we have done is we have divided this closed loop integral into 3 parts, and along how we are writing dr vectors along each part, this is important. These two are simple, but along part 2, because our dr vector is depending on y cap and z cap, we have to We have to also write the equation of this AB line, and we wrote the AB line equation. Then we convert our z variable in terms of y and then solve.